Hola.
How's it going?
It's going well. It's going well.
It's me, Baz. Yeah.
I know, Mas. I know. Nice having you back.
Great. Nice to see you.
How is life in Europe?
Weather, it's rainy.
Oh,
It's good to work. So nothing to miss. Yeah, I got plenty of work, but it's fun. So not missing anything.
no. Typical. Let me give just 1 or 2 more minutes before we start with the club, with the crazy club. It's really amazing here now. How have you been? Were you able to check some of the things for this week? How was it?
Look, I checked on the inputs. I did some. I did a short research on this Dust challenge, and I had a look on this Dust problem a year or 2 years ago, because you have to imagine in apartments. In any apartment, you have dust. The dust it concentrates always on the wall. Yeah, Dust has a great dust solving problem business model. Yeah, it's great. And dust in space, it's a problem because
It's a giant problem.
it's a giant problem because it reduces the lifetime of your equipment.
Joe, and I see that Joe, you went to this. I saw your links in there, pretty cool, man. Joe, thanks for making the time to put some research on it. Okay, that was impressive in the board
Yeah, glad to be able to join. I don't have the best internet connection, so I'll listen in, and I'm on Figma.
Oh, you're on. Okay, cool. I see that. Yeah, you've got a new name called Jumpsuit. That's I got it. Is it an orange jumpsuit?
It's a nickname my wife gave me, and it's been my internet handle for a long time.
Oh, really? Because the reason I'm saying this, it's because NASA is well known for their blue jumpsuits and their orange jumpsuits. Very well known. It's like, if you want to see it.
As long as it's not an orange prison jet.
That's a very interesting one. Okay, okay, let's get started. I just wanted to ask you guys before we start one question. That is, why? Very briefly, okay, I'll tell you mine as well. But why do you space is your thing? Why are you interested in space? Like, was it because you've seen it in a movie? Well, why was that? I can tell you mine. Okay, I've seen Battlestar Galactica. It's an very old sci-fi series that it presents a lot of challenges for humanity. And there was this giant spaceship, passing by Galactica, and it brought the 12 colonies to be saved. And these guys were like, in the middle of, call it nowhere in space, with the hardest possible technology, avoiding communications because of the AI silence. And it had a noise like, I know there is no noise, okay, this is an invention, but, and below in my house, when I was a kid, there was a butcher shop, and they had the same noise in their. I always thought that whenever I was walking down the stairs, I'm hearing Galactica in space. And that and the dreams of being an astronaut said, I have to do space for my living. So that's really, it comes down from my 12 years old being doing that. What is it from your side that moves you into space?
Well, Gonzalo, my interest in space is kind of similar to yours. I've been I flew an airplane before I drove a car. I've been involved in aerospace since before I can really remember. And even though my career path doesn't mirror that in technical terms, I'm not an engineer. I've always been around aviation, spacefaring, but I'm also a pretty big fan of science fiction in the space side of things. I've several book series out there that are fantastic to read and listen to. But I think there are many great challenges out there that need to be solved in space. And I wanted to do more than just read about it. I wanted to be part of the movement.
Step by step. And I'll show you today parts of how to become part of the movement and how can that help as well. And what about you, Bas? Why do you want to do space, man? What's in it? What drives you from the inside?
Yeah, I'm basically science fiction. I'm science fiction driven. Yeah, and but in other way, I didn't have the opportunity to get in contact with space because it's such a challenging. It's so challenging in many perspectives, on the business level, on the engineering level. But I think it's the next most logical step for humans on planet Earth because we will need more resources. And this challenge to expand into space on an economic level, that's really fascinating. I'm a guy, I'm basically into challenges. This is in so many levels and so many perspectives, so challenging. It's incredible and at the same time fascinating. And so, yeah, that's why I'm trying to get into it and I'm really curious to learn more. What is the perfect perspective and form of thinking and building thinking patterns to get humans into space? That's really fascinating. And that drives me, the challenge.
Hey, I'm going to be away from my mic for a second.
Yeah, okay. That's interesting, man. That's really the challenge. I think the challenge is a very, very important driver.
The challenge of evolution. Right? Evolution has become so fascinating on so many levels, and being human is great. Yeah.
Being human is great.
Being human is great.
So let's get a head start into our thing. Thanks for that, man. It's kind of. I hope today's challenge. I'm gonna brought you a couple of things that I'm doing so that we can later check on.
Thank you for having me invited. I'm really, I'm fascinated. It's great.
That's fantastic. I'm going to open up the Joe's file and we'll do like 10-15 minutes on that, and then we can do the rest by ourselves. But I'd like to start with that because I think, to be fair, this chapter is very, very important in terms of it plays out the role of what's called the Scrum Master. That is, it's someone that really knows about the domain, knows about the process. While the product owner knows much more about what's in there. So let me share my screen.
In the Scrum Master class, and that happens here in Module 3, Chapter 3, Build, where they actually experience it. They see speed go up while quality climbs, so we can break that limiting mindset. We often ask seminar attendees how they felt using ranking of happiness on a scale of 1 to 5, so that attendees can see which practices also were correlated with the most self-reported happiness. So we want speed to go up, quality to maintain or increase, and even happiness to increase. So we measure all three. The happiness index is a self-reported scale. What we build depends on the class. The effect we want is a build exercise that increases the confidence of the soon-to-be Scrum Masters. During a seminar, the effect of the build exercise is dependent on how refreshed and supported the instructor is at that moment. Really, if I'm the instructor and I'm exhausted, I can't pull the right behaviors. I can't try to pull the optimism that we need for people to see the happy outcome. It's not like I make it happen, but I've got to be ready to receive the students' positivity and pull it. And I think that's true for many instructors. For those of you that are already teaching class, you may know intuitively what I'm trying to talk about. Joe Justice has created a study of 71 Scrum seminars taught in North America, South America, Europe, Asia, and Australia. These seminars represent more than 3,500 attendees. All attendees self-organized their own Scrum teams with Scrum boards and the 3 Scrum roles, exactly as you did in Chapter 1, Introduction. The teams then build things in 3 or more sprints. Some teams choose to build Lego cities. Some teams wrote software. Some teams folded paper airplanes. Some teams designed and built entire cars with Joe Justice and raced those cars to celebrate. In every case, teams were forced to stop work at the end of each sprint, and their Scrum Master was asked to facilitate a retrospective. How to facilitate an excellent retrospective will be covered in more detail in Chapter 15, Demo and Retro. Here, we will summarize. A retrospective is done or complete when the team has chosen what they will do differently next sprint to be faster and happier and higher quality, or at least maintain quality. The purpose of a retrospective is to choose a process improvement. A process improvement is also referred to by the Japanese word kaizen. The word kaizen has become popular among process improvement professionals, many of whom study the Toyota production system, which uses the word kaizen, which is the Japanese word for good change. After this process improvement, or kaizen, is chosen, the teams start their next sprint. Every sprint, the product owner writes on the group Scrum board a measure of how much work met the quality bar and is therefore done during the sprint. Quality is also measured and labeled. What we have found is that in all 71 seminars, velocity increased across the sprints, the amount of work that met the quality bar, so only quality work. And in 70 of the 71 seminars, quality also increased across the sprints. It did not matter if the seminar was in Tokyo, taught in Japanese with executives and engineering leads from NEC. It did not matter if the course was in Australia with a mix of military special forces and regular army and civilian specialists. It did not matter if the seminar was held in Tesla in Silicon Valley in the USA. It did not matter if the seminar was in Germany with older, arguably stodgy engineers with decades of entrenched opinions. It did not matter if all attendees were C-level, like CEO, CIO, CFO, or new hires, or even if the attendees were students and kids. Almost no classes were students and kids, but I did have a few. And it did not matter if we were folding paper airplanes, writing software, drawing CAD, cutting aluminum, laying up carbon fiber, programming electronics, laying out circuit boards, or playing with Lego. Every team sped up. 99% of them increased quality while they sped up. So the point I've just tried to make is there is an exhaustive study that I conducted that did show it's not only possible, it's more than 99% likely. Speed will increase with quality also increasing, and I'll show later happiness also increasing by doing kaizen, by doing retrospective. So the teams are forced to pause, measure quality, measure output, measure happiness, and then say, what will we do differently next sprint to increase those? Just by doing that, by applying an inspect and adapt process, those metrics can increase. In fact, they did in almost every single case, far and away the majority of the time. This experience might be the most valuable for building confidence in people taking the class. They experience it and they think, okay, now I've done it. Maybe now I can help other people do it. The quotations from respected industry leaders help a Scrum Master know they're in good company. So it's not just the Scrum Master that's experienced this in class, but they see respected industry leaders who have also experienced this and also endorse it. If anyone says this Agile stuff is silly, they would also be saying the CEOs of most global companies are also silly, along with the most exciting startups globally. And that helps insulate a Scrum Master from criticism. So it's important in the class to show social proof from respectable sources. That reduces the amount of heckling that the instructor might experience. In some classes truly are aggressive. Scrum is being done to the employees. So you need to structure the class so that it removes the ammunition and allows everyone's mind to open up together, which is what I'm trying to lay out here. These are relatively advanced instructor techniques. Please use them. The business case studies showing success.
Okay, I want to pause in here, Bas and Joe, to take a bit of editorial, but going back to the drawing board, to the Figma board, and introduce you the rover design. And I've got something very cool. I think it's very cool for you guys to look at. So we are here. Oh, I should have cleaned this one up in here, but okay. So I want you guys to look into two different things. One, they are, let me take this off from here. But essentially, we are looking at this initial construct from 1972. That's the moon rover that really rovered in the moon. Okay, just to have an idea. So it's not this one, okay, but we'll use this architecture as a foundational principle. And the cool part of here is, again, you've got some very astute research in here that I pulled up for everyone to see. Okay, this one in here. Let me open up and give you a very, very brief explanation on that. It's from George Sanders. He's fabulous. Okay, but the most important part in here, or what you are looking for, is the utilization of space resources will allow us to have launch mass saving, reduce the number of launches, reduce costs. And here is the nice thing to see. Bas, can you, okay, so the cool part in here is that we see that for every 202 kilograms on Earth of thing, man, it's equivalent to 1 kilogram of propellant on Mars. And this is the main reason, one of the main reasons why we need to start having these propellant plants on the moon, essentially on the moon. That's the place where you can go and use ISRU and bring it up. Okay, so this package is really, really full of great information. What I would highlight this slide number 4, where we can understand, wow, this is why we are building propellant plants, or we will be building propellant plants on the moon, and this is why we need a rover. Okay, so the whole idea is that we are going to mine polar water and volatiles, and for that we need landing pads and excavate regularly. So the use cases are around here. Okay. So excavate regularly, move those things in there, and processing essentially O2 and even methane. I want to. So this is really good research. This is probably the one of the best things that I've seen there. And the next one that I would like you guys to think or look into is, we have, I would say, two major trends. People doing space mining, including me, okay? And how my challenge is to produce a rover that to do space mining, and then these big companies like JAXA and Toyota. JAXA is the Japanese space, the NASA of Japan, and they substitute Toyota, Nissan, Lockheed Martin, and General Motors, and again Lockheed, Northrop Grumman, and also associated. So it's really this type of transport people and cargo, and these ones in here will likely do mining. Okay, so my business, my thing, is to start around here, to start in the mining side where there is more engineering to be done. There is more fun. I would say more fun mostly because we can adapt change. Okay, so the two use cases that the focus is mining the polar water volatiles and extraction here. And this is the baseline that we had in 1972 when it landed on the moon. They are still there. There are 3 rovers over there. Some folks say that if we take some batteries from here and then flip it in there, they might even work. You might not believe it. It could be true. Okay, but this is the reason why we need rovers to do that. Okay, so I wanted you guys to focus on that. And later on, this is the type of that I'd like you guys to fix, because this is my life, and here in a certain way, we have a set of requirements to fulfill, and it's also a tree of requirements that have been built up. And then from here, We have a physical architecture, is mobility systems, electrical, thermal. So the things that exist in the world, okay, a real thing. So you see the real thing. The real thing is over here. There are more designs, but it's always good to see an example of what we are talking about. If you go here, you can see our, the extract is this, but it has the prospector in here. There's something coming from NASA with the camel lock, but it has a radio telescope. But our part is just, it's this one in here that will have a hopper in here in the center. So it's a real thing. It's not like invented stuff. This is, as you can see, it's in the position where it needs to move. For drilling. So what you'll hear when you hear me talking about things like physical architecture, the physical architecture is the thing that the system has. It could be also a software architecture for those domains. So extract physical, and then we'll also see me talking about function. It's what things do I need to do. Okay. And so this gives you an idea, like you need to obey the requirements, so you have a thing that exists and the things that it does. And then we try to connect requirements to each one of these components in here and see what are our gaps. So this is where if in fact I'm doing. So I would like you guys, please, both Das and Joe, to take a look into our mining rover, that is these components, requirements, physical, and do a very brief thing like connect one requirement. I hope this will connect one requirement, a specific system. Okay, so it's essentially. Oh, this is a reverse. This is a cool. Must not use wired umbilical power, only on board power system. So I'll give an example. This one, it's electrical power. Okay. So I know that these requirements needs to be satisfied by electrical power. Can you do that in a 2 minutes thing? So what we are doing is we are allocating requirements to systems. Okay. Is that good, Robert and Joe? Let's try it. Okay. Pick up one, pick any, and then just connect it. Okay. See what's gonna happen. And one requirement can be connected to many systems. Okay. To many locations, and later on even to functions. Just read one and pick it up, and let's see if we can do that. I'll do the same as well. So you pick up the arrow in here, connector. Pneumatic systems. And if you don't know exactly the answer, I would say sometimes it's easier to connect it to. Oh, thanks. Very fast, man. I'm connecting it to a higher level system because it's not always that we can connect things to immediately to a subsystem. Okay. Okay. Yeah, jump. Okay, cool. Time. So this is what we would do in the first part of any system. It's to define the requirements, define even the scope and the purpose, understand what's the physical architecture, and then from the physical architecture, understand, okay, what is it being done? An excavation can be, divided in prepare the drill, review the position, plug inside, collect sample. It could have a whole set of functional decomposition. So the next logical task is to decompose this, but also then to connect the requirements that we have in there, and later on put what's called measures of performance. Okay? So that's something that we can do. But Great job, everyone. Okay, so you are putting your hands into a space system, in this case, the extract. Thanks for that. Any questions? Bas, Joe?
I don't have any questions right now, thanks.
Okay, so one thing that you see in here is that I didn't divide the requirements into performance requirements. We are just allocating stuff. Okay, so this system needs to go along to this requirement. This is saying how we need to do it. This is what is the power of the motor, what is the overall type of so that's something for it. But right now, it's important whenever we do this type of things to allocate the requirements. And you guys were awesome in that with immense speed. That was pretty cool. Let's go back to Joe. And reload this. It's real slow.
Structure the class so that it removes the ammunition and allows everyone's mind to open up together, which is what I'm trying to lay out here. These are relatively advanced instructor techniques. Please use them. The business case studies showing successful company restructuring using Scrum teams gives a roadmap to replicate, so people can take some of what happened in other companies and repeat it in their company, or at least understand that it's possible. We will have more on Justice's law to complete company restructuring in Chapter 13 Sprint and Chapter 16 Switch. I'll actually add that now. And Chapter 16 Switch. The repeated positive business outcomes assure us that Scrum teams as company structures can work across many types of work, maybe even all types of work. Actually doing it, actually building something ourselves in a Scrum team using Scrum in class creates a deeper confidence. Part of this is seeing the group Scrum board metrics from our own team and all the other teams attending our seminar. During the build exercise, the metrics ramp up to an organizational performance level we likely have never been a part of before. I mean, really, these speeds double and double again, sometimes even more than that. It gets really exciting from the people doing it once they see that their exercise is real work with some valid metrics for quality and happiness and output, quality output. That creates confidence. Now, our trained Scrum Master can walk into a company full of Agile teams, and our Scrum Master can see if the teams are simply using Agile words or if they're using Scrum to get performance, because they can see is performance climbing or not. So if they come into a company and they look at their group Agile board and none of the metrics are increasing, they know they're not doing retrospective. They're not doing furikaide in Japanese or Kaizen. Our trained Scrum Master now knows how to look at a Scrum board and see speed and quality, or if the Scrum board is not used, or worse, hiding a team that doesn't yet know how to do Scrum. So some teams might even lie on their Scrum board and show that quality is climbing and speed is climbing. So the Scrum Master must also look at the real product output, the product increment, to see if it matches the board. That's part of coaching. So how to do Scrum in class? Let's use two examples, the airplane game and the Wikispeed car build. The airplane game is great because it is so portable. The airplane game was first defined for grade school students by a team of brilliant educators in 2009, and the link is here. Those educators are Teresa Abney, Adam Nathan, Don Knob, Lisa Picker, and that was documented on June 9th, 2012. But when they documented it on June 9th, 2012, they referred to doing it in 2009. The game can be run anywhere. We can get a full stack of paper from the nearest office printer. We can step into any venue, anywhere, and reasonably expect the physical requirements to be meetable. The car build is the entire opposite. This activity requires, at a minimum, all the raw materials and tools to create a car. In exchange, the exercise is entirely more memorable. Joe Justice still has past students stop him in the airport, or now on Zoom, because I'm not traveling as much at the moment, to take a picture together and sign a book, saying the car build they did together however many years ago is still the highlight of their professional life. That type of business performance impact is priceless. But again, the logistics are literally heavy. I mean, to ship all the tools and materials to construct a car, it's basically the size of a car. I shipped them via airplane once. At that time, it was just over $10,000 US to send them from the United States into Potsdam, Germany. I think it was right around 10K to send them by airplane. Sometimes we can ship them by a trailer or a truck or a car, and that might be $5,000, $2,000, maybe even less than $1,000, depending on if a truck's going somewhere anyway, but it's a big deal. And it's physically labor intensive to pack the vehicle, prep the vehicle, unpack it, pack it up again. But basically, you add 3 to 5 additional days on top of the time you're gonna build the car with the students. It's exhausting. It's really physically intense, and it consumes the entire day. And then you just need to sleep for a while afterwards, or at least I do. But it's super fun when you make a car. The good news is a build exercise can be run with any type of work, provided it meets the following criteria. The work must be able to be completed and judged for quality within the sprint length. For a car, or at least in sprint 1, the entire product is unlikely to be completed within a single sprint. We were running often 45-minute sprints, sometimes as short as 15-minute sprints. I think we even did 5-minute sprints before. In that case, the product must be modular, where each module is able to be completed and tested within the sprint length. That's what I was doing at Tesla. By the way, you have just grasped why modularity is necessary for Scrum companies or all Agile companies. Modularity is used to fit the entire design, analyze, build, test, deploy cycle into a single sprint. For a massive project like the Tesla Semi or Cybertruck, it must be modularized, and the modules must be able to be built in parallel. In that way, if we have a big project like a Wikispeed car, which is composed of 8 modules, and if we have 8 teams, we can complete the car and test it within 1 sprint. Now that you know the secret, we will return to the build exercise. First, let us conduct a masterclass on the airplane game. So I'm going to try to say how to enjoy taking a class with the airplane game, the learning objectives of the airplane game, how to teach the airplane game, and expert level instruction of the airplane game. That's what I'll attempt to do now. Here we go. Each Scrum team.
I'm going to pause in here and go back to our Figma board to keep us moving in our game in there. Okay. And we'll that airplane game, it's really phenomenal. It's not one of those things that you can play along. But what I would like to look into with you guys, it's the reason it's looking into our physical architecture. It's kind of, I decompose this into something, into things that could be, you know, it's like look at the rover, look at the vehicle and say, oh, cool, this is it. You know, these are the main things, the main, let's call it subsystems, to find the name that is used over there. And you see that we can have mobility being built in parallel, the electrical power as well, the thermal regulation, navigation, the extractions in the transportation system, the dust. If you guys done the other, if you guys remember from last week, we did the dust and all the requirements that come from the dust. So all of the things that here you have it, all of the things that you have in here. Joe, all the things that you had in here. Look at industrial physical pole observation. So all of these things, and plus this, then I also added something else, would be further requirements that need to feed into the rover architecture. Okay. Now, I so I see a lot of very interesting questions in here. Yeah, Bas, can you move it slightly up? Cool. Okay. So I would ask, have you guys ever built something like this? Have you ever built a vehicle end to end, or how has been your experience on that? Joe, Bas, have you ever built a vehicle end to end? Testing down the wheels and doing
the unmuting wasn't working. Hey, so I was a project manager for a company that built conveyor systems out of stainless steel for food manufacturing companies. So I'm very familiar with the requirements for cleaning, hygiene, you know, dust and water mitigation, things like that. I haven't done a vehicle, but I'm also very experienced with, well, I'm experienced with vehicle production, but not in the, I did classic car restoration as a job. It's an old job, long time ago, but I have been all over earthbound vehicles. So because I wanted to work a bit in here to work in two things. As one is, I need some requirements, and at least I need your view on what would be requirements for maintenance. From your view, from your view, let's put a couple of things in here, maintenance requirements, and then let's then allocate them to a set of systems. Can that work? Yeah. So one of the things I learned as a project manager for the conveyor systems was that you had to design with future maintenance in mind. So for instance, when you put a bearing in a certain location, if you can never touch that bearing again, that bearing will fail at some point in its life. And if you can never get to it again, you're absolutely going to be stuck with a critical failure of a minor part. So, especially when you're looking at mobility, thermal regulation, transportation, I think those areas are going to be really key. Electrical power isn't as big of a deal. We hide wires all the time. And usually the issue isn't in the wire, it's in the component attached to the wire. But of course, you're talking about the moon, so who knows, right? So yeah, those, I think the extraction subsystem is going to be crucial too, because a minor bearing fault in an extraction subsystem could sideline your rover in half a second, and you'd be stuck on the moon with a moving bot that can't do its job.
Absolutely. So what I wanted to reach out is because of these conversations, and we'll do this with your teams as well, these things will come along. And these three requirements in here: excavation, regulated movement, and conveyance, mobility and traction. There is no such thing as writing down that one of the functional things, one of the things that the rover needs to do is to be maintained. We have to have some kind of maintenance operations. And as we talk about these things, as we talk about the full life cycle of the vehicle, we need to have a maintenance operation in there. So that's something really, and to have a maintenance operation. Okay, so what are the requirements for the maintenance operation, and what does it mean maintenance for each one of these subsystems? Okay, so it all keeps tying it up. Okay, Joe. So that's, I don't know if you do this with your teams, but that's usually a method, isn't it?
So Gonzalo, one thing I would recommend is clearly identify the expected service life of your rover, right? So if your rover is expected to operate for 6 months on the moon autonomously, that's a lot different than a 3 to 5 year service life. You're going to need different spare parts and for a different length of time. So make sure you pin down how long you think this thing's supposed to work.
NASA asked, and you guys will see in the challenge, NASA asks first phase, 15 days, and I'm writing it down, 15 days of durability. And durability essentially is the ability to maintain a system working intervention without a breakdown. So there is no such thing. Figure out this, it's like if you put gas on the tank, in this case, you need to charge the rovers, and during 15 days, at least on Earth, they will keep on working without any human intervention. On the moon, the ask in here is slightly different. We should be able to excavate. Make sure that I give you the right. That I give you the right numbers.
Yeah, 15 days may not sound like a long time, but really, when you're talking about digging equipment, 15 days is a pretty big ask.
It's a completely crazy ask to me.
Yeah. Yeah. So, when you talk about 15 days of digging, you're talking about, very high grade metals for your digging tips. You're talking about, long duration battery life. You're talking about some pretty big requirements there. It's not just as simple as putting a shovel in the ground.
No. It's not that. Let me give you the expectation in here. So, the most relevant thing here is durability. Okay, this is the equipment design requirements that we had that I've shown you that you guys were starting to allocate. And then, so this is essentially how the equipment needs to work. But what is really the question that you had is, okay, what does NASA have to say? Teams 15 full 24 hours long Earth days until fail. So this needs to be working within 15 days. And there is the cool thing, okay. On Earth, we need to excavate 12,000 kilograms of simulated gravity during these 15 days. This will be working continuously. That's a very cool and interesting thing. So this, I would say, this provides the 15 full 24-hour long Earth days, okay, or until it's failure. I hope this has answered. We haven't imported yet. I haven't imported yet the requirements into there, but I'll do that so that we can continue some of this work. Okay. But
Yeah,
as I think,
so in there, I see you have two different ways you can go about this, right? It's either trips or capacity. I see that it's, there's a distance 500 kilometers. Oh yeah, you're thinking about the same thing I'm thinking about. You either design for a low capacity and many trips or a high capacity and few trips. So how are you thinking about splitting that hair?
so I'll give you the direct answer. We are going to have 2 rovers with capacity because we have a constraint on the total mass landed, and if one of my rovers messes up, because it can, I still have the other one. And we are still making some trade-off studies on should we have 3 or should we have 2. One option would be to create one large scale big thing, but it's a single point of failure, and you cannot live with a single point of failure in a robotic system. At least that's not intended.
Yeah, strong agree there.
If you guys want to think about, if you want to expand that to other sources, other things in the space environment, if you think about a rocket, most common in the small launch industry, the flight termination system is the single point of failure, because that's the only thing that everything can break, but that thing cannot break. If the flight termination system is something that allows you, after the rocket launches, it allows you to say, okay, it's heading to a dense population area, or getting out of trajectory, and you see some of the marks from the range, and to say terminate flight, bring it down in this location. Because most of the rockets these days, at least for small launch, okay, everything is a single point of failure. Everything got let's say we have one engine, we have one first stage, we have one second stage, so you don't have 2 second stages. So you need to go down even a level lower and see, okay, what's the thing that can really break that? In our case, rover, it doesn't provide us the reliability, although we are trying to design, so as you go here, each one of these systems to be reliable enough and having parts of high grade. Having 2 systems will, the moment we finalize this analysis in here to create the system with the right load within the 10,000 kilograms, and when we run some simulation model on this, and then when we build the thing, let's see what the data can do. This was a long explanation to we have to. That's how we thought about it.
I think that's the right answer. And another thing to keep in mind is the keep it simple, stupid process, right? So whenever you're designing for reliability, minimizing complexity is a huge thing. So, in areas where you can use something as simple as like a Raspberry Pi type board with some basic programming, you may actually gain reliability just simply by keeping the programming simple. I know as big term thinkers here, we like to really make things more complicated than they have to be. And this is a complex problem, but breaking it down into subsystems will help bring in that simplistic mindset.
So that's what we were doing in here. If you, I think if you want to dive a bit more and reach out to George Sanders, the key, let me play this up because it's everything. The use case, the use case is a big name, but it's essentially the thing that we are to dive into is this one. So I'm going to spare you to look into all of them, okay? It's this one. So the functions over here. So these are all the functions that you need to provide. Traverse back and forth, these are endpoints, plant, resource, sun, and down. To do so, this, if one thing that we do often, is to reuse things from others with proper with I know that these are all the use cases, okay? So select the location for drilling, interact with the solid right-of-way, interact with the SRE plant. This is not yet in this challenge, okay? But we know that for the future, our rover needs to interact with these. So both either when we dump the materials, you see here. So anything that has to do with interfaces would be vastly more complex than anything else that is just inside the system. What I mean is this.
Oh, absolutely.
One thing is we say, okay, let's do our. Oh, yeah, see this is Janet. One thing is doing just the mobility system, but anything that has all the connectors between mobility and electric. So
Yep.
one thing that needs to be adding here to be stressed is, okay, what are all the functions that are already needed? Then we can start allocating requirements. And if we start thinking about this, there is an ISRE plant, we might need to think that, oh, my extraction, my transportation subsystem must have an interface to the ISRE plant. And that is not even, it was not even in the design yet, but it will come in. So
Right.
It's something that appears as much as you are looking at, oh, this is what my client wants. What's the interface to that? So that's really fun. I would say one of the more fun things to do. So this gives you an idea of that engineering work can be just massive. And
Yeah.
but in all here that I wanted to give you guys is in 1 hour, we can come up with a system architecture, a functional architecture, requirements architecture. These are all architectural stuff that needs to be done, okay? But the cool thing is to build it and then test it. Okay, that will be interesting. I wanted to get back a bit more into Joe. Okay, I don't know if you guys have the time to listen to the chapter 2, but I'd like to give it 5 more minutes, and then we should break for the week. And I have some ideas of assignments that we can do together.
Sounds great. And Gonzalo, if you want to talk about this later at some point, I'll give you my phone number. We can have a chat. I think that'd be great.
Okay, yeah, absolutely. I will. It's 5 more minutes of Joe. By chance, I was, well, he was in New York, the New York City Alliance, Scrum Alliance this week. If you guys had the time to do that. But he did mention this and the work that we were doing, so that was fun. That was really fun.
Let us conduct a masterclass on the airplane game. So I'm going to try to say how to enjoy taking a class with the airplane game, the learning objectives. We'll come back to this point at the end of sprint 2 of this exercise. The airplanes must be, which we call the space pod, to nesting 4 or even more sheets of paper on top.
I'm just gonna pass pass ahead the airplane game. I think if you guys have time to do it in your
Game has a lot of instructions. I saw even more people only. I want to simulate innovation and the design process. So here is what I'll show. We're going to have a sprint. They're going to plan, have a daily meeting, a sprint review or demo. They're going to have a retrospective, and they'll repeat that 3 times. At the end, they'll have group Agile demo, group Agile sprint review, and group sprint review, group retrospective. And that's at the end after 3 sprints. A sprint is a small project. Each sprint has 5 Scrum events. Each sprint ends with giving a delivery to the customer. Teams are free to fold any type of airplane they want, use any design they want, organize the work any way they want, have anyone perform any step they want. This is important because I don't want to simulate production only. I want to simulate innovation and the design process. So I don't tell them what airplane design to use, and I have to stress they can use any airplane design they want. And in fact, the airplane design should probably evolve across the sprints. Now it's an R&D and production and test project.
Okay, I'm gonna pause in here because I'm gonna capture some notes from you guys and I've seen that Bas already placed some of the things, but for me this is crucial because the work that I'm doing, in case you guys are also helping out in there, is a combination of research, innovation, and production. And mostly I want to hear from you what we see as mostly what you guys see as problems into deploying the structure that you see in the plan, daily sprint, demo, retro. So if you could put some of your notes. I have a couple of some of them. For me has been one of them for me has been to convince the team to work like this. Convince the team on the method. I don't know if you have others. Oh, you were specific. Okay, you went specifically to. Well, let me send this one to Joe. And I have a promise understanding interfaces. And in my case, it's also a question of power budget for the 2 rovers, power budget for the end-to-end operations. As you've seen, they increased the number of operations with the functional architecture. It's like, heck, how am I going to, how much power do I need? So another thing in here is how do we convince budget? Thus, the considerations, what do you see as potential problems on applying both the airplane game, and I like your idea, man, the airplane game in a virtual team, but thus, how do you apply, what are your problems with this airplane game and making the build occur? And I'm talking about exactly this life cycle. It's cool that we've got it on screen. Bas, are you there? Okay, Bas is not there, then now. Joe, any final remarks? Why the planned daily demo retro, group retro into a group, even in the most challenging one, that is the people working remotely with physical hardware, with physical stuff.
Yeah, so he does make a comment in this chapter about applying Scrum to the CEO level or C-level team as a direction Scrum to kind of combine and identify what the next focal point will be for the remaining teams. And he also brings up an interesting point that in each sprint, you have to have a deliverable from all teams simultaneously. And I think that's something that needs to be, noted, that the goal for each team must be achievable at the end of each sprint.
Yeah, I think that thing that goes down to the definition of them. Having something that is achievable, let me. Man, as a project manager, I'm sure that you've faced it like things. This is impossible to meet at the end of.
Yep.
At the end of the month, we'll have these 15 projects done. Everyone will be working like this, and we'll have 5 orders and this and that. It's like, but we don't have enough people. No, but the metrics said that.
Yeah. I'll need
Yeah,
about 28 hours a day to accomplish this. Exactly.
But the worst thing, I've been in similar situations. Like you want to design 15 processes and implement them in the next month, but for some years the maximum that I could have is 6 per week. So like really good tools. Like we'll do 16 in 3 days. Okay? Guess what happens? We don't do 16.
Right.
But the metrics go out as that, and everyone is happy. So it's a weird thing that this kind of expectation keeps on going without being sanitized. So how to sanitize expectations? Okay, guys, it's 4 p.m. So this went really fast. I'll be bringing you a bit more of. I'll be bringing you a bit more of the project that I'm doing. Our new role between our requirements, physical architecture, functional architecture, and then also something that you guys can see something here is.
I'll be done in just a second.
The interface management and how I think that's listening to this. Okay, yeah, what would be the MVP in this? And like some of your comments, pretty cool.
That's all. I'm going to have to bug out. I'm going to send you my phone number on LinkedIn. Sorry.
Yes, thank you very much, guys. Enjoy the day. Bas, thanks for coming. Joe, thanks for coming, and see you next week. Okay. Cheers.
Yep. See you. Bye.
Bas, see you next week.